Good day. Welcome to our video on angles and geometric figures, focusing on composite figures. A composite figure is pretty much a combination of different shapes forming a different figure. So let's go to our first problem. ABCD is a rectangle, AEDF is a rhombus, and angle CDF is equal to 65 degrees. We want to find angle DAF and angle AED. So let's try to label that so we won't lose our way. Angle DAF is this one, and angle AED is this one. What we also have to consider is that ABCD is a rectangle, so all of these angles here, these tiny ones here, are right angles. I think that will play a part when we solve. Okay, and we have a rhombus, and if you know what a rhombus is, it's a parallelogram with equal sides. So you know that these are equal to each other. So it's interesting to note that this angle over here is 90 degrees because it's a rectangle, right? But this angle over here is 65. So you can actually solve for this angle by subtracting 90 degrees minus 65 degrees, and that will be 25 degrees. Now if you notice carefully, the rhombus actually is divided into two isosceles triangles. So the angle DAF has the same measure as angle ADF. So we've already solved the first item because angle DAF is 25 degrees. Now that covers this triangle over here. And we have to keep in mind that we still have angle AED over here. We do remember it's a rhombus though. And in a rhombus, the opposite angles are equal. So this angle here is equal to this angle here. And we can solve for this one because it's in a triangle, an isosceles triangle to be exact. So for number 2, we have to solve for angle AFD, which is 180 minus 25 minus 25, and that is 130 degrees. And since angle AFD is equal to angle AED, we can say that angle AED is equal to 130 degrees. And this is an example on how to use the angles in geometric figures to solve for other portions or other angles, as you can see here and here. Let's have another example. I'll read the problem. ABCD is a parallelogram and CDEF is a trapezium. ADE and BCF are straight lines. Angle DBA is 32 degrees and angle ADB is 28 degrees. So there's a parallelogram, that's the one in green, and a trapezium, that's the one in blue. Now let's use the properties to help us solve for first angle DCF. That's this one. Let's label that DCF. And then we want to solve for angle CDE. Okay. So let's look for DCF first. We know that this is a parallelogram, ABCD, and the angles opposite each other are equal. So that means this one here is the same as this one. Now it's interesting to note that ADE and BCF are straight lines, meaning since it's a parallelogram, these are parallel to each other. That makes the lines that cross these two as transversals. So what does that tell us? If it's a transversal, that means this angle here, that's 28 degrees, is the same as this angle here. So that's 28. And since this is a parallelogram, the sum of 32 and 28 is the same as the other side. So that means this is also 32. And now we can solve for the other angle over here and the other angle over there. So we know that the sum of the angles inside a quadrilateral, any quadrilateral for that matter, is 360 degrees. So let's subtract 60, because that's this one, 32 and 28, and subtract another 60 from the other side. So that will result in 240 degrees. And that's the sum of the other two angles that are opposite each other. So 240 degrees divided by 2 is 120 degrees, meaning this is 120 degrees, which gives us the answer to angle DCF, because angle DCF is along a straight line with 120 degrees over here. So angle DCF is equal to 180 minus 120, and that is 60 degrees. So this is 60 degrees. Now to solve for angle CDE, we also have to consider the fact that this line over here, just draw that, is a transversal too. And you can confirm that because 28 plus 32 is 60. That's this one. And it's same as this one. Now, what does that mean? First, you can actually solve this angle here already by checking this angle out. You already know right away that the alternate interior angles are equal. So this is already 120 degrees. You can check because it's an angle along a straight line. So 180 to be sure minus 60, this one is 120. I hope you were able to see how the different properties and patterns of angles and geometric figures are applied to solve these problems. And before I bid you adieu, I'd like to challenge you. Can you find a shorter way to solve for DCF? And if you can message me and we can discuss. For now, that ends our video. Till next time. Goodbye.